You can see what time it is. It's 9:23, 36 seconds. So by Unix time, it is. You can see it's 1,351,275,819. So recently, that's the first time in my life that I was tracking Unix time, and I knew that the last time I looked at it was 350. And when I looked at it again this week, it was 351, so it rolled over a million seconds. And how long is a million seconds? Well, as you know, it's like 11.5 days. And I know when I had my million-second birthday, because I worked it out in advance, because my whole life, since I've been 8,688 days old, and I was born on February 19th, 1972 at 1722. When I worked at my UTC Sparks, my Sparks time, but now I learned that, and I knew the power of integer time is because you can bookmark things. So here we can take down some Unix timestamps. So right now we know it's 1,351,000, and we're writing down our first Unix timestamp, 275 and 887. So that's the first one that we saw. The one that we read out was 1,351,275. What did we call that? I forget. So this is the past that I forget. I called it out. I said, did I say 8? Oh, you're testing my memory now. So you can see in terms of the neurobiology and benign memory lapses and the connection that we're describing here. And so that's the timestamp, and we're going to go through. I've been working on the Rubik's Cube again, and recently I solved the Rubik's Cube, but I had to use the algorithms. And as a kid, I worked out how to do the top two layers, and I can't ever remember using the instructions, because maybe they didn't exist at the time, or maybe they did, but I can't remember if I looked at them. And I was still working on the last two layers, and I didn't push through it to get to the solution. I know I wasn't looking at a solution. I was figuring it on my own. I knew the principle of doing algorithms that would morph the cube back to the same place, but after doing rotations, you realize that it takes one cube to another cube, and that kind of morphing and iterations, that kind of chaotic stuff, is basically, well, it's not the same, but it's the same principle as cellular automata. Rule number 90, and the bifurcations that you get with simple rules making complex dynamic systems. Now, of course, it's different doing a Rubik's Cube, but I've read Stephen Wolfram's book on that. So I just realized that with feedback and iteration, you can get nesting down in chaotic patterns that are called strange attractors and chaos theories, such as the Sierpinski triangle, which is actually rule number 90 of Stephen Wolf. You can see the boundaries between complexity, and you can see how in biological systems maybe the conch shell, because it's laid down in the same way, maybe the protein pigments are interacting in feedback loops that nest down to that stable pattern, because it's pointless. Like, the colors of that shell prove nothing. So we're going to go back and look at what I'm eating in the place. So we've defined this line that I want to get the GPS coordinates, and I know I got it loaded there. I got the string really tight because recently I really realized that I wanted to add an extra dimension to my flat, and the only dimension I could think of was the string. So I put under tension with the bulldog clip and the thumbtack. But if that thumbtack popped out and hit me in the eye, and let's say I predicted that's going to happen, so in the next 60 seconds and how many minutes, so I would say that at this time in the future, like I'm predicting this now, so it'll be, we're going to add 1,000 seconds. Yeah, let's say we'll add 2,000 seconds, so, 277, I just say 500. Like, if at that time, which is time, at that place where I'm standing, if that thumbtack flying through the air because it pops out because of the plastic deformation of the resin of the paint, and it struck me in my eye, and I defined a point and time. Let's imagine I was filming it, and I caught that on film, and it really happened. Well, I'd be fucking famous for predicting it. But it's a hypothetical thing about connecting a point and time in the future. That's not how life is. So, just in case it happened, I'm wearing glasses while I'm in the hallway with that string under as much tension as I can get it under, because I'm predicting the unpredictable. See, that's how I trade, though. I'm trying to trade that way. So, naturally thinking about risk assessment, and that risk assessment applies to all industries in terms of that whole thing on risk management and what are the risks. You can see the string. Maybe if I wave the light, you can see it better. So that whole kind of industry got to think about the statistics of those kind of cataclysmic things happening. That's just how life is. So I was looking at my salad, and I'm not sure what country it's from, but it's not from England. And just imagine the carbon footprint of that, and how dead we're going to be when that carbon runs out. Because Norman Borlaug, I'm pronouncing his name wrong, he's from U.S. He was the father of modern agriculture, and because of his modern techniques introduced into the world, India, Pakistan, and Mexico within 2 years became net exporters of wheat, but they were also buying U.S. agricultural equipment, like Deere tractors and Caterpillar and stuff. So basically the whole world, not much of my food covered, the whole world is supported by this cheap energy we get out of the ground in the Middle East at $2 a barrel. But the Henry's law, Herbert's law, about the distribution of oil, we're past peak oil because we've gotten all the easy stuff into the 800 oil fields in the world, and most of them are in decline. And there's what's the world population clock now? 7 billion? I checked it last. I'm just looking at my veg, where's my salad from? Last week I had Italy. I had Italy from Rocket. I had Rocket from Italy. And this onion, where's this from? Oh, it's a UK onion. Well, that's a fucking miracle. Oh, British people. I don't know why I bought this. I buy it once every 2 months. And, every kilogram of beef that we eat, it takes, 15, 20, 30,000 liters of water to raise? And, there's pig. Okay, there's 3.4 billion pigs in the world? Just think about how bad to have all those pigs in the world are. And all their shit and their gas and the atmosphere. And, and all the basically soy that we grow in the U.S. we give to bloody cattle to raise them, and then in South America they're raising cheap cattle, ship it to the U.S. from McDonald's for their cheap consumers to eat and get fat, and the spread of obesity all across the U.S. So let's look at the topology of the social network of how obesity spread, and no doubt with people and how they're internally connected, and then what their eating habits be, and how habits spread, and how it was acceptable to get fat in the U.S., and what percentage of Americans are fat and overweight, and all the excess, and the 40% of food that the nation wastes, and meanwhile the rest of the world is in famine. This is the U.S., and we want to think about the world, but Africa would be down over this side, so we've drawn the Earth, the North Pole here. But down in Africa, and there's no food, and they all live on wheat and World Food Aid, because those countries, Mexico down below, that's making lots of wheat, and India over here. India is a big net exporter of wheat, as is Pakistan, because of Norman Borlaug's agriculture techniques. It's crazy that in India, 20,000 tons of wheat rotted, clearly left in the stalls because of the supply and demand dynamic, and they didn't want to drop it into the market to drop the price of wheat because they want to keep the prices up in terms of that future derivative. There must be 4 different wheat future contracts, but anyway, meanwhile in India there's 3,000 starving. Yeah. The world's a bit fucked up when you think about the interaction of all these complex dynamic systems and the scales of complexity between the small and the big, and how exponentially fast it grows, and how big the network gets at each level, and what all the possibilities are, when you start looking at all the possibilities and how all those challenges presented tasks for evolution for the brain to get more advanced over time, when you look at how many neurons are in the brain per three-dimensional space and what the current 14 nanometer technique is for etching microchips, when you compare the brain versus the microchip, you look at, I think, over 4 billion years, the brain has gotten to a certain density. I think not as fast as we have with nanotechnology. So, this Moore's law. Eventually, humanity needs to create a nanotechnology that can self-organize so that a general artificial intelligence can emerge in the future and basically take over the world, or at least create its own kind, so that if the Earthlings are doomed, then at least a general AI could go on and study the cosmos. But when you let a general artificial intelligence into the world, and it can access quantum computation, where you look at the qubits and the superposition and it existing in all states all at the same time, and the Heisenberg uncertainty principle, and you look at allowing bifurcations with connections, creating a superposition of qubits, and how they can solve NP-complete problems. They can not just do serial computing along a binary line, or in terms of Turing's computers, or however you want to do computational events, which is generally linear and serial. You want to do them if that's the x and the y axis in terms of 2 dimensions or 3-dimensional computing. But when you add time into the equation, which is the 4th axis, when you make it 4th dimension, we're describing almost like a 4-dimensional sphere. So that's quantum computation. It does all solutions all at the same time, so it can factor large prime numbers instantly, because right now they're 128 bits, that we can't do these equations in a meaningful time, because it doesn't mean nothing afterwards. But if we don't solve this energy crisis, the whole world is absolutely doomed. And I think a general artificial intelligence can help that. Help that, really. That's just random ideas for tonight. You can see what time we're at. Where's my Unix time?